So hello everyone, this is lecture 8 for the nuclear physics. The last lecture we have started the radioactivity, and I was telling you that how we will discuss the successive decay, that is A to B, B to C, C to D. But here in this our syllabus we will study up to C only, A to B and B to C, and we will consider that it will become stable after that. So there are a large number of questions asked from this section, so you must pay attention here. So initially we will assume we need to find now rate equations that how A is changing with time, how B is changing with time, how C is changing with time. So we need to find the equation for them. So initially at t equal to 0 there was n naught nuclei of A only, and B will be 0 and C will be 0. Now at time t this will become Na, or we can say n1t, and this will become n2t, and this will become n3t. Now sum will always remain n naught because one nuclei will convert into the 1 and one will be converted into the 1. So this is 1 to 1 line. So that's why this sum will always remain n naught. So now we need to find that how A is changing with time, B is changing with time, and C is changing with time. So it is 1, 2, 3 you can write here. So let's first find for the A. Means A is converting into the B and it is constant lambda 1. So we already know this thing that how 1 is changing. Means it is depending that at particular time how many nuclei are present. That is minus lambda 1 n1. So we already solved this equation, and just take this dt this side and n1 this side. This will give you n0 to n1, and this will simply n1t as n0 exponential minus lambda 1t. So we know for the n1. Now the task is to find for the n2 how for the b, means how b is changing with time. Now see, as A is disintegrating, so as one nuclei disintegrates from A, it will increase one nuclei into the B, and at the same time B is disintegrating into the C. So there were two factors, means increasing and decreasing in the B nuclei. So how they are increasing, that will be depending on the n1. Means it is decreasing by rate this, means 1 is decreasing by this rate, so B is increasing by the same rate, that was lambda 1 n1, plus is because it is increasing. Now what is the rate at which this B is disintegrating into the C? This will depend at how many are present at particular time at B. This will be minus lambda 2 n2. So minus because this is because of decreasing to C. So this is the complete thing, means increasing and decreasing, and net will give you that how n2 is changing with time. So if lambda 1 n1 is greater than lambda 2 n2, that means n2 will start to increase, and if lambda 1 n1 is less than lambda 2 n2, that means n2 will decrease. Means this will greater means there will be more nuclei are increasing in the B as compared to decreasing into the C. Okay, that's why it is increasing. But here it is saying that there was not that much nuclei are producing into the B, but more are decreasing into the C. That's why n2 will decrease. So that's how you can see this. Now we need to solve this equation to find the n2t. So take this to the left hand side. This will become this. Now see, we just multiply a factor exponential lambda 2t in the whole equation. You will see that why we are multiplying, because of the differential equation we know how to find a solution. So just to multiply this, this will become this. Now we multiply this because now you can see here, this simply if you take the differentiation of this product exponential lambda 2t and n2. Now if you differentiate this using the product rule, you will again get this. So we can just summarize this into this. That's why we just multiply this factor exponential lambda 2t, and here it will become lambda 2 minus lambda 1 t and it is here lambda 1. Now we need to integrate, so this will become exponential lambda 2 t n2, and now this will integrating will give you lambda 2 minus lambda 1 factor here. You know how to integrate, and now there is no limit, that's why we have to take this constant of integration also. Now to solve this or to find the C1, we will use the initial condition that at t equal to 0 there was no nuclei of n2 present. At t equal to 0 there was no nuclei of B, that is 0. So n2 will be 0 at t equal to 0. So at t equal to 0 put n2 equal to 0 and solve this for C1. This whole term will be 1, so C1 will be minus n naught lambda 1 divided by n2 lambda 2 minus lambda 1. So this will now C1, this is equal to this, so substitute this value this here and you will get this equation. Now to find the n2, just divide this whole equation by exponential lambda 2t and you will get your answer for n2t. So that will be n2 at any particular time, it will be n naught lambda 1 and lambda 2 minus lambda 1 exponential minus lambda 1 t minus exponential minus lambda 2 t. Now this is your equation for the n2 and you have already for the n1. Now what is for the C? So see, for C this will be very easy because C is not disintegrating into something any other nuclei, but C is already only increasing, and that is depending that how many are present at n2. So it will be simply lambda 2 n2. Now, or it is very simple to calculate the n3 that is n0 minus n1 minus n2, because sum of n3, n1, n2 will always remain n0. So n3 will be given by directly n0 minus n1 minus n2. So just substitute the value of n1 and n2 from here, and you can calculate the n3. Now next task is how n1, n2, n3 are decreasing, increasing. So we need to plot them. So how can we plot them? So to plot this, let's see first for the equation for the n1. So what was the equation? That was n1t as n0 exponential minus lambda 1t. So n1 is decreasing with time exponentially. So you can see directly with time it is decreasing. So for n1 it is simply going n0 to exponentially decreasing. But for the n2 we have this equation d2 by dt as lambda 1 n1 minus lambda 2 n2. So see, it is some increasing factor is there and decreasing factor is there. So initially n1 is greater, n2 is smaller, but with time we will see that n1 is decreasing and n2 is increasing. So this at some point this whole thing is now initially is positive, but at some point it will become negative. So what is this? This is slope. So first it will be positive and sometime after that it will be negative. So it is showing that at some point the slope will be 0. So this graph must go like this. That's why we are getting this graph. Now this equation gives us this, and you can understand. Now for n3 we have this equation lambda 2 n2, so it is always increasing. So you will get this equation like this, and it will tend to n0, means that when all these are decreasing to 0, this n3 will become approximately n0. So you must remember this curve for all the how it is decreasing and increasing. So what we calculate here, this was your average mean life time for any particular nuclei, that is 1 upon lambda. T half is nothing but log 2 by lambda, and rate equation for n1 n2 we calculate these, and for n3 it was simply n0 minus n1 minus n2. Now there is one numerical based on this. Find the time at which intermediate nuclei B has maximum number. So for B we need to find the time at which this n2 is becoming maximum. So we just put this slope is equal to 0 and we can find the value for this point. So this is your value for n2. Now dn2 by dt put equal to 0. So that will be simply just take the differentiation, and it will give you this equal to 0, and from here this whole thing will be 0, and you can calculate this, and from here simply time will be log natural log lambda 1 by lambda 2 lambda 1 minus lambda 2. So this will be the time at which this slope will become 0, and this is your maximum value of B nuclei. Now there is two more terms are remaining, that is radioactive equilibrium. So we have two kind of equilibrium, there is secular equilibrium and that is transient equilibrium inside this radioactive equilibrium. So what is secular equilibrium? Means see, at any point if some nuclei is remaining same, means the number of nuclei are not decreasing, increasing, it is remaining constant, then we will say that that particular nuclei is in the secular equilibrium. Any member in a radioactive chain is said to be in radioactive equilibrium with its parent when net number of nuclei of such a member doesn't change with time. This is your parent, this is daughter, and this C. Let's say this B nuclei is in the radioactive equilibrium. So this N2 means nuclei of B must remain constant. So dN2 by dt, we calculate, this was your formula. So this is constant, then this must remain 0, and this is your condition to be in the radioactive equilibrium. Now you must remember this. If they say in the question they are in the radioactive equilibrium, you just substitute this value and you can find the values. This is the condition for such a type of radioactive equilibrium, and it is called the secular equilibrium. So must remember this. Now what is the condition? Means this is just a formula. What is the natural condition we can see? So we can find that if it is in the it can be, or possible reasons are there to be in the secular equilibrium. What is the condition? How the condition of secular equilibrium can be achieved? Now see, if this lambda 1 is very less than lambda 2, then what will happen? This whole term will tends to lambda 2, and this lambda 2 is very greater. This is exponential minus, so this will become approximately 0, and you will get only this term, and here it is only lambda 2. So this equation will resolve to lambda 1 by lambda 2 and not exponential minus lambda 1t, and this is nothing but n1. So it is simply n2 lambda 2 equal to lambda 1 n1. So we achieved this condition by what factor? Means what we consider first? We consider that lambda 1 is less than lambda 2. Only then we get this condition, this one. So what is the conclusion here? And this lambda 1 is nothing but 1 upon tau, that is parent nuclei, means this is the average mean lifetime of parent nuclei, and this is for the daughter. And if lambda 1 is very small, That means this average mean lifetime of the parent nuclei is very large as compared to daughter. Means this is the condition. Means for the parent nuclei, the average mean life must be very much larger as compared to daughter nuclei. Only then this condition can be achieved. That means if this lifetime is 100 years, then this will be some 100 days. So that's how, if this condition is satisfied, then you can get this equilibrium. So you must remember this. This can be asked in the interviews. There is one more kind of equilibrium you will find, that is transient equilibrium. Now in this, lambda 2 is not very much larger than lambda 1. It is simply greater than lambda 1. Means if it is 100 years, this will be some 40 years or 30 years. So that's how the factor is there. But one cannot neglect lambda 1. Means now we can't neglect this lambda 1 because they are comparable. So what you will get? See, this term can't be neglected, but here this lambda 2 is greater, and this is exponential term. So that's why this value will become very small, very fastly. So that's why this factor will be neglected, but this can't be neglected. And here, now again, if this is greater, then this tau parent must be larger, and this tau daughter must be small. Means again the lifetime must be greater, but not that much greater as in the secular equilibrium. So what is the thing here? In the initial stages, when time is less, both the exponential terms will be comparable, but as time increases, this term will start increasing very much, and this will tend to 0, become very small as compared to exponential minus lambda 1 t. So this will be neglected, and this will become n2 equal to lambda 1, n naught by lambda 2 minus lambda 1, exponential minus lambda 1 t, and this is n1. So this is your n1 will go this side, n2 by n1, this will become this, and this is constant. Now see, what is the factor here? Means now this ratio is remaining constant. Means here we said that this number is not changing, but here we are saying that this ratio is remaining constant. Means to the parent nuclei and the daughter nuclei, this ratio of nuclei will remain constant. Means they can be increase or decrease, but this ratio must remain constant. So that is called the transient equilibrium. In transient equilibrium, ratio of number of daughter nuclei to the number of parent nuclei remain approximately constant. So this is the difference between the transient equilibrium and the secular equilibrium. So that's all for today. Thank you everyone.